Good afternoon, everyone. I'm Ong U. I'm Program Manager with the Azure Storage team. I'm with my colleague, Surya Skutian.
Yeah. Hi, everyone. My name is Surya Skutian. I'm also a Program Manager on Azure Storage team.
All right. Let's get it started. So we're going to talk about premium storage today, right? And we announced general availability of premium storage 3 weeks ago. And this is the first time that we have ever presented premium storage at the public conference. So we are very excited about this opportunity. Thank you. So, thank you. So we have a lot to cover today. So we'll take the questions at the end of the session. And both Sirius and I will stick around as long as you need to answer any questions about premium storage. So before we get started, let's try to understand how many of you have run a VM on IaaS? So it's about half of the audience. How many of you heard about premium storage? That's good. That's good, more than I expected, because we announced it 3 weeks ago, so this is good. All right. Session objectives and takeaway. 3 objectives. Number 1 is that we would like to give you a lay of the land of premium storage, its key features and capabilities. And number 2, we'll go underneath the hood, and we'll explain its architecture and key design components. And objective 3 is we will explain best practices and pattern so that you can use those guides and then you can run your real-world applications on the premium storage platform. So those are 3 key objectives. Key takeaways are 2 things, 2 key takeaways. Premium storage is an industry-leading. Premium storage provides industry-leading performance on Azure IaaS VM, and this is a very unique and compelling feature of our premium storage. Number 2 is that you can run demanding enterprise applications on premium storage, such as data warehousing, OLTP, and any other application which requires high IOPS and low latency. So, all right. What is Azure Premium Storage? So let me give you a little bit background of Azure Premium Storage before I jump into that. Azure Storage has been around for more than 6 years. And since the release of IaaS, Azure Standard Storage Disk has been, Azure IaaS VM has been using Azure Standard Storage Disk since release of IaaS. That's the standard storage. And with the GA announcement of premium storage, Microsoft Azure Storage offers 2 storage types. One is standard storage, which runs on HDD, and another is premium storage, which runs on SSD. And what is premium storage? It provides high I/O performance and low latency. And what we did was that we made we added major features and improvement on the storage platform, such as we made improvement on hypervisor layer, file system layer, and networking stack. And then the storage stress is running on SSD to achieve high I/O performance and low latency. So those are the improvements that we made. Ideal for I/O intensive workloads. What are the applications? We look at it, we work with the customer during preview, and then right now customers are running SQL, Oracle, Cassandra, MongoDB. They are running on our premium storage right now on both Windows and Linux platform. Thank you. Key features and capabilities. Well, high-scale VMs. We offer DS series VMs. Those are the high-scale VMs. And then premium storage support that VM type now. So what it does is that premium storage VM supports more than 64,000 IOPS. 64,000 IOPS. performance on the Azure DS series VM. This is unique in the industry, that the IO performances, the IOPS performances are unique in the industry. And then you can attach up to 32 terabyte of premium storage disk. So a little more about that. 32 terabyte is that the largest disk that we offer is 1 terabyte. So you can attach up to 32 of them, or you can stripe, if you want a larger drive, you can stripe 32 of them and then get a larger disk. And we provide up to 512 megabytes per second disk throughput. So while we provide very performance solution, we continue to provide highly durable and available. What that means is that once your application writes data to the premium storage, it synchronously writes 3 replicas of data to the storage platform, and then it acts back to your application once all three has been durably written on the premium storage disk. So this is also very unique in the industry. We provide so key takeaways from this slide are that we provide very high IOPS, low latency, and then we continue to provide very durable and high available solution here. Let's talk about geo expansion. Currently, we have that in the 6 regions. So what is next is that our goal is to offer premium storage on every region that we have around in the near future. A little more about DS series VM. We talked about it. That's a new VM class to support premium storage disk. And then there is a very unique architecture design component there, which is enable us to achieve those performance goals, which is blob cache. I have a slide dedicated for that, so I will explain more about blob cache in the later slide. But what it does is that it provides a caching layer using a local SSD and then RAM SSD, so that you can get a better throughput, and at the same time, if there's a cache hit, your latency will be very low, right? And also, in addition to that, in addition to blob cache, we also offer local SSD, so that if you have like a temporary processing that you need to do on the VM, you can use the local SSD. Another thing worth mentioning is that you can mix disk sizes on the premium storage. It may be obvious to you, but it's worth stating that you can. We will talk about the different disk sizes, and then also you could make standard and premium. So they are like IO-intensive application. You will probably attach premium to run it, and then standard storage disk to like store data, which doesn't require IO performance for cost optimization purposes, right? So DS series VM. We offer 8 variations of DS series VM. I do not list all of them, but one thing that I want to highlight is that, let me see. I have my little laser pointer, and then I plan to use this for this occasion, but I cannot find a laser pointer, so I just have to talk it through. Actually, I find it here. A couple of key things I want to call out. DS14, this is the maximum largest size of VM that we have offer, right? So RAM size, we offer 112 GB, and the local disk size, this is a local SSD size that I mentioned, 224 GB. And key thing is the maximum disk performance. This is a write performance number of write IOPS that you can get. It's 50,000 IOPS. And then if you enable cache on the local disk or cache on one of those premium storage disks, you can achieve up to 64,000 IOPS. So we will go over one of the configuration, but essentially, if you combine those two, you can achieve more than, both read and write combined, you can achieve more than 100,000 IOPS on a single VM, which is DS14. Moving forward with premium storage disks, so we offer 3 premium storage disk types, P10, P20, and P30. So what we offer is that since we guarantee IOPS and throughput per disk. You will need to provision, so since we guarantee that you will need to purchase one of them which fits your I/O and throughput requirements. Pricing. So provision disk size, I mentioned to you, but provision disk size, it's prorated hourly, but based on the monthly fees. So what monthly fees is that based on the disk size? This is one of those prices, this is per month fees on one of those disks. Right. And a couple of key scenarios, it's what mentioning here. If you need P30 disk, I mean, if you need 1 terabyte, pretty straightforward, you will get P30, right? And depending on your IOPS and stuff like that. However, let's say if you need 700 GB, but you only need 3,000 IOPS, you could strike, well, if you need 600 GB, but you only need 3,000 IOPS, what you can do is say you can strike P10 and P20, which would give you the GB requirement, and then also satisfy the IOPS requirements, so you don't need to purchase P30, which is slightly more expensive. So that's one of those cost optimization that you can do based on your requirement there, right? And the price is a sample because I just want to caution to you that it's vary per region. So let's go inside premium storage. This is, we just want to go, we want to go underneath the hood and explain premium storage. So we want to go over key design. There are three key design components that I want to go over there. One is DS series, which supports disk caching, right? So the reason that we can achieve this throughput and IOPS and low latency is that the reason is that DS series VM supports disk caching. So how do we do disk caching? This is a unique component and a unique technology in the industry, which is blob cache. It's a caching layer. What it does is that you can turn it on either data disk or local SSD. So on local SSD, you can enable both read and write caching, but on the data disk, you can enable read only right now. So, but the point is that if you mix and match, right, if your application is read intensive, and then if your application is read intensive, and then write could be through data disk, but you can configure cache on the local SSD and the read intensive. With this combination, you can get a lot of IOPS. And that's one of our demo scenario that we plan to show it to you also. And another thing, another point, another key component is that persistence data on Azure storage. All premium storage data disks are page blobs, and then each disk are persistent on Azure storage page blobs, and then each data that you write to, we keep 3 replicas. So those are the 3 key components. Let's deep dive a little deeper. The intent of this slide is giving you an overview of our scale limits in each of the layers. So first layer is the premium storage disk layer, and then we call it disk level provisioning. So you need to understand each limit of each of those disks, IOPS and throughput. So each disk, you can provision up to 5,000 IOPS, and then 200 megabytes per second. And you can attach up to 32 of them. But combining with another layer called SSD, which is a blob cache layer, which you can turn it on either, so you can turn on caching on the premium storage data disk or local disk. And then if there's a cache, it doesn't count towards your allocation of 5,000. That's extra. That's a 64,000 limit. 64,000 limit that you do. So if your application is a read, and then if there are a lot of caches, that's the additional 64,000 that you can get. So combining that, all the writes will go into the Azure page blob. And then there's another layer of scale limit that you need to be aware of. That's a VM network level provisioning level. So each VM network level, so at the VM level, the scale limit is at 50,000. So there's a Sirius is going to go over best practices. So go over like, hey, how do we tune that based on the IOPS, size of the IO size, queue depth, and etc., so that you can optimize your application and run your application and get the most maximum limit with understanding all those three-layer scale limits. So Sirius and I will be tag teaming and then showing you a demo of a couple of key scenarios.
All right. Thanks, Ong. Okay, let's make sure the machine is all set up. For the first demo, we are going to use a Windows machine. So it's a DS14 VM with 11 disks attached, 11 premium storage disks. 10 of those disks are going to be used for write workload. So we have turned off caching because we don't need caching for writes. And we stripe those disks together to create one volume to make it easier, and that's what we will use for our write workload. And 11th disk is going to be used for read workload, that's where we are going to demonstrate the performance of cached IOs. So for this, yeah, if you look at the Explorer view here, the disks at the top are like your OS disk, your default A drives, E drive, and the temporary storage. The two disks at the bottom are the premium storage disks. The F drive is the striped volume that's going to be used for writes, and G drive is the one disk that's going to be used for reads. And now if you look at the disk manager, just to see how they are configured. So you can see we are using storage pools here. We use the typical storage pool setup. There's nothing different about that. We have the two volumes up there, and we have the disk underneath each of those. Okay. Now for this test, we are going to use a tool called IOmeter for driving up traffic on those disks. We are going to run the micro benchmark, and we will measure the IOPS and throughput performance of those disks. And we are going to start with the write workload. So for here, we are going to use 8 KB IOs on those volume with 10 disks, and we'll see the IOPS limit that we are going to get for that particular workload. All right, on, let's go. Okay. All right. So as you can see here, so we are getting a workload somewhere around 50,000, just like Ong showed on the other explanation, with 10 disks, each having 5,000 IOPS limit. Across the 10 disks, you can get 50,000 IOPS. And as Ong said, this is the highest number of IOPS you can get from any other VM in the industry. So it is one area where Azure VM is better than all other competitors. So we feel really good about that. All right. For the next part of the demo, we will look at the read workload. Here we are going to use the one disk we set up for reads, and we are going to run 8 KB reads only on that disk. And let's see the IOPS we are going to get. All right, Ong, let's go. All right. So right now it's around 65,000 IOPS. We have a little bit more than the 64,000 that we spec here. Once again, and here we are seeing over 64,000 IOPS from a single disk on that VM. So none of our competitors have a VM that can give you 64,000 IOPS, or even let alone a single disk that can give 64,000 IOPS. So we feel really good about that. Okay, that's great. So we used 10 of the disks for writes and a different disk for reads, right? So do you think we can run these two things together?
Sure, why not?
All right, let's try that out. So let's run the exact same workload, but both together, reads and writes. All right. So here, all 11 disks are being used, 10 of them for writes, 1 for reads, and you can see the IOPS around 100,000. It will slowly tickle up as the cache picks up. So you will expect around 100,000 IOPS. So once again, very large number of IOPS you can get from a single VM, far better than any of the VMs out there in the market. Okay. All right. So before we move on from Windows demos, we want to show one more thing. So what we have shown so far are the IOPS demos. IOPS is important for OLTP workload. We want to get high IOPS for that type of an application. There are some other type of applications like data warehouse workload where throughput is very important. So we want to run the same workload as the last one, which one got 100,000 IOPS. We're going to run the same workload to maximize the throughput. And for that, we're going to use large IO sizes. That's how you can get high throughput. I'll talk a little bit more about that. So let's run that workload here and see what happens. All right. So here, as you can see here, over 1,000 MB per second throughput from the DS14 VM. So we essentially double the write bandwidth of the VM with the use of the cache. All right. Great. Thanks, Ong. So that's what we want to show for our Windows demos. So we want to also look at the Linux machine. As you know, Linux is just as important for Azure. So we set up a similar, exactly same configuration with Linux. It's a DS14 VM with 11 disks, 10 of them striped together for write workload with cache off and 1 with cache on for reads. And we're going to use a tool called FIO for running the IO workload and measuring the performance. All right, let's go. Okay. So here this tool spits out the reads and writes IOs separately. So as you can see, it's around 50,000 for reads and writes. So together they're kind of close to 100,000, just like you saw on the Windows demo. So just to recap, so we have the Linux performance at par with Windows. So I know that some of you may have Linux-based application workload. And in Azure today, there are a lot of customers who use Linux on Azure. I'm sure Linux performance with premium storage is really going to improve the experience for those Linux workloads. Okay. All right, that wraps up our demo for now. Okay.
Right.
Okay. All right, so let's come back to the slides.
Yep. Oh, sorry.
5, should be 5.
5.
Okay, so it should be up in a second.
Yep.
Okay. Okay. Now let's quickly look at the configuration that we use for demo. So I can explain exactly how we got the IOPS and throughput numbers that we just demonstrated. So we ran 3 scenarios, as you know. Scenario 1 was just the writes. Scenario 2 is the reads, and then the third scenario is reads and writes combined. So first scenario essentially looks like that. We have 10 disks, no cache, and each of them capable of 5,000 IOPS. And since there is no cache, those disks go through the VM network limit for disk traffic, which is 50,000 IOPS. So that's how, in that particular workload scenario, we have 50,000 IOPS, and writes are ultimately happening from Azure storage page blobs. And for the second scenario, we have a completely different path from the one on the left side. So in this scenario, the uncached disks are not used at all. They are just there, but there's no traffic going through them. The only traffic going through is on that one disk that's cached, and that scenario gives up to 64,000 IOPS. And the third scenario is where we ran both these workloads at the same time. So we have the write paths going through the Azure storage page blobs, and the read path going through the blob cache, giving combined together around 100,000 IOPS. And in this scenario, it's really making use of the blob cache technology that Ong explained earlier. Okay. All right. So with that, let's talk about some best practices for premium storage. Now, when it comes to using premium storage, there are many variations possible in the kind of configuration you pick, or how you configure your application workload, the traffic patterns. And the performance that you experience and the cost that you incur will really depend on that. So in the next part of the session, we will talk about, we'll go deeper into these aspects and talk about how to optimize all these variables to suit for your specific workload. So I will go into 4 different topics, all related. We'll talk about service specifications, the traffic pattern implications, migration scenarios, and backup DR methods. Okay. Before I get into my first topic, let me ask, how many of you have actually used or tried premium storage in our preview or in production so far? All right, great. About half of you. Okay, that's good. So you're familiar with some of the topics that I'm going to address here. Thank you. All right, so let's go into the service specification aspects. So here the main thing to know is when it comes to configuring your premium storage system, there are essentially 2 things to pick from. You need to decide what VM you're going to use, VM or VMs you're going to use, and what are the disk sizes that you need. So premium storage currently supports DS series VMs. We have VMs with cores from 1 through 16. DS14 is our most powerful VM, and as I demonstrated, that VM can give up to 100,000 IOPS with the right configuration. There are other smaller VMs also available, each with different specific number of cores, the IOPS, the bandwidth, and even the specific cache I/O limits. So your goal will be to pick the right VM that's required for your application workload. Let's say you need 20,000 IOPS. Then you must pick a VM that gives you 20,000 or more IOPS. If you pick something smaller, it's not going to work for you. So that's the kind of things you need to keep in mind when you select the VM. So I will go into some more details on that in the subsequent slides. Now, when it comes to disk sizes, there are 3 specific sizes available for premium storage at the moment, each with specific the specific capacity, IOPS, and IOPS and throughput. So here again, you have to pick the right disks based on what your application performance requirements are. So we will go into details of that also. All right. So let's first look at the VM limit. Let's see how VM limits matter. Okay. So in the example here, I have a DS1 VM, that's the smallest VM, with a P30 data disk. P30 is like 1 terabyte disk. So P30 disk will give up to 5,000 IOPS and 200 MB per second throughput. And at the same time, a DS1 VM can go up to 3,200 IOPS and 32 MB per second throughput. Now, what will happen if this VM tries to drive up the traffic on that P30 disk? Can it drive the P30 disk to the max limit of the disk? No, it can't. This VM can only go up to what that VM can go up to, which is 3,200 IOPS and 32 MB per second. And if I were to illustrate the same thing in the chart, right below the table, the vertical axis on the chart is the traffic, the level of traffic, and the two dotted lines represent the VM limit and the disk limit. So if you were to drive the traffic up on that disk and measure it going up and see how high it can go, the chart will look something like that. So it'll keep going, and then when it reaches the VM limit, it stops right there. It can't go any further. So what this essentially tells you is that if you need to drive the traffic, if you really need to get the max performance from this particular disk, you need a bigger VM. This VM, DS1 VM, cannot drive the P30 disk to its limit. Okay? So that's about the VM limit. Now let's talk about the disk limit. So now that we know the VM limit, disk limit will be fairly straightforward to understand. It's just the other side of the coin here. So in this example, I have a DS4 VM. It's an 8-core VM with a lot more IOPS and throughput, more than 2,500 IOPS and 256 MB per second throughput. So in this case, the limiting factor is really going to be the disk throughput. What that means is that when this VM tries to drive up the traffic on the disk, at some point it's going to get capped at the disk limit. The VM cannot drive any more traffic than what the disk can provide. And on the chart, it will look like this, where it will go up to the disk limit, and it can't really get to the VM limit. So what this means to you is that if you want to get more performance from this configuration, you need to add more disks. Each disk will give you 5,000 IOPS and 200 MB per second. If you want more IOPS, you need more disks. Okay, all right.
So are there any plans for a best practice configurator or chart?
Right. So we'll come. Let's hold the question to land. So that way we can address it properly in that. Okay. All right. So in the third example, I'm just calling out. Let's say you want to push the DS14 VMs to its limit. The best configuration you can get for a premium storage VM is a DS14 VM with 32 P30 disks. So that has a theoretical limit of like 160,000 IOPS across all those disks and a really high throughput. But this is a theoretical limit, because the DS14 VM can go only up to 50,000 IOPS and 512 MB per second throughput. I'm talking about the right IOPS here. I'm not counting. I'm not thinking of the caching here, just to compare. So in this case, really you get capped at the VM limits. What it means is that if you want to really use a configuration like this, then you have to design your workload in such a way that either you will drive some disks to the peak at a time, and you can't really drive all the disks to that peak at the same time. So you may have varying patterns where some components get used at different times, or you may have a lower usage across all the disks. Okay. Now let's quickly look at the IOPS and throughput. Those are the other important aspects when it comes to understanding how the premium storage specifications play out. So throughput is really a function of IOPS and IO size, as you can see here. So throughput really is the total amount of data, the traffic that flows through the system. So if you have a lot of IOPS and the bigger IO size with those, that will increase the throughput. So as an example, if you have 1,000 IOPS and each IO with 8 KB IO size, we are looking at 8 MB per second throughput. Now, the main thing to remember for designing premium storage is that IOPS and throughput in the system have separate limits. For P30 disk, for example, there's a 5,000 IOPS limit and 200 MB per second throughput limit. So these are separate limits measured and enforced separately. So that means that when you design your traffic and your disk, you need to make sure that both IOPS and throughput stay below the respective limits. Otherwise, what can happen is that if you try to get maximum IOPS by increasing your IOPS, you might run into a throughput limit somewhere else, and that might cap out at IOPS. So those are the controls you need to be aware of. So we will talk a little bit more about that, how to control the IOPS and throughput independently. Okay, so that wraps up the first topic. Next, let's go into the traffic patterns. So I'll start with the implication of I/O size. This is closely related to the IOPS and throughput topic we just covered. So what I want to talk about is the importance of I/O size in controlling throughput versus IOPS. So if you look at the formula, IOPS, when you multiply IOPS with I/O size, you get the throughput. So what that really implies is that if you want really high IOPS, if you want to increase your IOPS as high as possible and not worry about running into throughput limit, you have to use a relatively small I/O size, like 8 KB or sometimes even smaller. That will ensure that you can increase your I/O size limit and not worry about running into throughput limits. So let's look at this example. So P30 disk, and if I have I/O size of 8 KB and if I do 5,000 IOPS, the throughput is coming to 40 MB per second. So in this case, I'm getting the peak IOPS from this disk. 5,000 IOPS is the max IOPS from P30 disk. But throughput of 40 MB per second is way less than the 200 MB per second I could get from this disk. In many cases, for OLTP workload, it doesn't really care. All it would care about is the IOPS. It really won't care. It really wouldn't matter if its throughput is less than what it can get. Now, if you think of a different workload, let's say a data warehouse workload, or some other type of workload that cares about moving huge amount of data, there it cares about getting high throughput, and it may not really care how many IOPS. It just want to move as much data as possible. So that's the second example here. If I use an I/O size of 256 KB, really large IOs, I can get up to the max throughput from this disk. I can get 200 MB per second, and I will only have 800 IOPS to get that. So just to say that in a different way, when you use 256 KB I/O size on this disk, you will peak the throughput at 800 IOPS. And for data warehouse workload, it really doesn't matter much. It's getting the peak throughput, and that's it. All right. So next topic I want to touch on is the queued up. So this is another question that keeps coming up. So this is very important when it comes to controlling your I/O within the limits. The queued up is really the number of pending IOs in the system. So it's like when you send an IO, it takes some time to get the response. If you send another IO at the same time, that gets queued. And if you send even more and more and more IOs, all those things get queued. So that's your queued up. So as you increase your queued up, your IOs also, overall IOPS also increase. But there are limits in the specification of the system, and you need to make sure that the IOPS and throughput stay within the limits. That's why it becomes important to control the queued up. So it's really, queued up is really a function of IOPS and latency. So in this example, if the latency is 1 millisecond, and if you want to maintain a queued up of 5,000 IOPS, you will need to maintain a queued up of 5. If the latency, if your workload pattern changes and the latency changes with that means that you need to alter your queued up to get the number of IOPS. Or if you want to hit a different IOPS, again you need to change the queued up. The queued up is a very important aspect for controlling the performance of the system. Okay. Now let's talk about a few specific ways you can optimize that. Essentially, depending on application, the queued up can be defined or controlled with different kind of knobs. Some application simply calls it queued up. Sometimes it's the I/O channels. Sometimes it's the threads in the application. So these are, and sometimes it's user control. Sometimes it's automatic. So it's very important to know how your application essentially controls the queued up depending on the system limits. And for striped volumes, you have to remember that you will need you will maintain a high queue depth because every disk needs to get the peak queue depth for that disk. Now let's see what happens if the queue depth is too high. If your queue depth is too high, higher than the optimal level, that will really lead to too many IOs coming from the system. As you increase your queue depth, it's really sending more and more IOs. And when those IOs go over a limit, it will lead to throttling. Either if it crosses the IOPS limit or throughput limit, that will lead to throttling. And throttling means lower latency, and the overall performance of the system, overall performance get degraded. And what happens if you keep your queue depth too low? So what that means is that you are not pushing the system hard enough. I mean, it may be fine in some cases, right? It all depends on the performance you need from the system, your application needs from the system. So if you keep the queue depth low, it means less traffic, low IOPS, lower throughput, overall lower utilization of the system. So you wouldn't want that either. Now, I've talked to many users who ran into situations where they're testing out premium storage, they're trying a workload and say, hey, I'm not getting enough performance. I expected 5,000 IOPS, I'm only getting 2,000 IOPS, things like that. And quite often all these turned out to be the case where the tool they use for test is not pushing enough traffic, doesn't have enough threads or enough queued up to really push the system high enough. So this is another thing you need to really control when it comes to getting the peak performance from premium storage. Okay. Let's talk about cache hits. I know Ong went in depth about how blob cache layer optimizes the overall performance with the use of caching. So this functionality, the golden chance to get the max benefit from premium storage. It's like you can really drive it to its peak limit by designing your workload and designing your configuration to make the best use of cache hits. So the thing, as Ong said earlier, the cache hits don't consume the IOPS allocated to the disk. If your disk has 5,000 IOPS, and any IO served from the cache don't consume the 5,000 IOPS. So that's why we could go on that one disk up to 64,000 IOPS, even though the limit on the disk was only 5,000. A couple of other things to remember is that cache has its own limit. It's not like cache is unlimited, it has limits. And those limits are 4,000 IOPS per core and about 33 MB per second per core. So those limits are a little bit higher than the limits you have on that VM for the write traffic. And these limits are shared by the local disk as well. As you know, there's a temporary resource disk on the VM. So if you have traffic going on that resource disk, the IO consumed for that is shared with the cache IO. So that will make the IO for cache, available IO for cache less than the peak available. And all IOs that you do on a cache disk will consume the IOs for cache. What it means is that if you don't expect benefit from, if you don't expect to gain from the caching, then you would want to turn off caching for a particular disk. Here is where it becomes very important to design your disks in such a way that you optimize which disk needs to use caching, which disk should not use caching. If you turn on caching for all the disks, you probably will not get the peak benefit from that VM, because not everything will be able to benefit from caching at the same time. The concept of caching is that the most frequent items will see the benefit. Most frequently read items will see the benefit. So you would want to design your workload, design your configuration by really looking at your workload pattern and pick the right configuration accordingly. Okay. So here are a few recommendations for cache setting. By default, we use read-write caching for OS disk. That gives the best performance for OS disk. That also means that you should not run your application workload on the OS disk unless you take extra care to flush all the IOs to make it persistent. If you don't do that, you may run into data loss, because read-write cache means that IOs don't get returned to the disk right away. So you will need, if you ever run application workload on OS disk, you have to make sure IOs get cached. IOs get returned to the disk, flushed to the disk. For data disk, by default, we set read-only as the caching. That is the best caching option to get the peak performance for that individual disk. But like I said, you should look at the overall system and decide which disk need caching and which disks don't need caching. And that's where the last point comes in here. You would want to put, you want to turn off caching for disks that are write-only or write-heavy, or in some way you don't want to use caching for the disk. Then you would want to turn off caching for that disk. Okay? Okay. Now let's look at how, just to recap, how to increase the IOPS and throughput with cache kits. So in the example here, and this is the same example we ran in the demo, with a single P30 disk. Under normal circumstances, it will give you 5,000 IOPS. With cache kits, it can give you 64,000 IOPS and 524 MB per second for cache reads. And second example is what I'm calling pushing beyond the limits. This is what we show in the third demo, where you have reads and writes on separate disks to get the peak performance from that VM. This is the one with 100,000 IOPS and around 1,000 MB per second bandwidth. Okay, so next we want to show you some. Okay, next we want to go back to the demo machine and really show you how you can get what kind of performance gain you can expect from premium storage. So we talked about a lot of ways to optimize the premium storage performance, right? So what it will ultimately lead to is a performance for your real life application workload. So for this demo, we are going to use SQL Server query performance as an example. So what I have here is a DS14 VM with 15 disks. There's one log disk and 14 disks all striped together into one volume. And we have a typical retail database, large database. As an example here, we have like 10 million rows in customer table and 100 million rows in an order table. And we are going to run some query. We're going to do some joins and run some queries on the order table and see the performance. And also, we haven't done any kind of database optimization on this. We want to show you the raw performance, so there are no indexes or any kind of optimization here. Just raw premium storage in action here. So let's run the first query. So first query is essentially joining the warehouse table with order table, which has 100 million rows, and showing a summary at the warehouse level. So let's run the query. Okay, 2 seconds. 4,000 rows in 2 seconds. I'm used to seeing a lot more time for this kind of query to come in the past. I think we have time for one more query, right?
Yep,
okay, so
do.
let's run the second one. So this one will join with the district table. So that district table has a lot more rows, I think about 10 times more rows. So let's see how much time that takes. So this is going to return a lot more records than the first query. I think probably 10 times more records. All right, so this one has 10 times more records and like 6 seconds. So we are really excited about the improvement in the SQL Server performance. I'm sure our SQL Server customers are excited about this. And this benefit, this gain we see is really across the board, be it Oracle, SAP, or any kind of IO-intensive application. You can see the same type of performance gain. Can we ask the question in the end? We'll come back to that in the end. That way I can finish it and then come back to it. Okay. All right. Now let's switch back to the slides. Before we move on from the SQL performance, so we just looked at query performance. So query is one of the aspects of SQL Server performance. There are other very important the important operations on SQL Server, backup, restore, create index, and several other stuff. Okay? I wish I could demo many of those things here. Unfortunately, those operations on a large database takes a lot of time, and that won't fit into this demo. So what we have done instead of that is to run similar tests on our side, and we want to share the results that we get consistently from those tests. So here are the operations and the configuration that we used. It's a DS14 VM with 10 P30 disk, and the database is really large. It's a 750 GB database. It's larger than what can fit into the cache. So there are a lot of things are not coming from the cache here, and it's a single table with like 7.2 billion rows and cluster index and so on. And as you can see, the time taken for these operations, this is like an order of magnitude better than what you would see from a standard storage today. Now, we also did similar tests on our competing platform. We want to make sure that it's not just about comparing standard storage, also comparing the competitors. And the results are amazing. Every single one of these operations on premium storage beat our competition. In one or two cases, I think at least 3 cases, we are over 100% better than our competition. So we are really excited about that. And we continue to work on making the platform even better. Okay, I'm sure all our SQL customers are going to experience this benefit. All right. So let's move on. So with that, wraps up the traffic patterns. So now let's talk a little bit more about cost of migration, cost of optimization scenario. So we'll talk about how to pick the right configuration for your premium storage instance. So as you know, there are 3 different disk sizes that we offer today. The important things to know about those disk offering is that it's, even though we say P13 is 128 gig, P20 is half a terabyte, P30 is 1 terabyte, those offers are not just about the capacity. Those offers are about capacity as well as performance. So you have to pick these disks based on what you really need for capacity as well as performance. So if you need high performance, then you would want to pick a disk that gives you high performance regardless of capacity, and vice versa. So that's the main thing you should keep in mind when you pick the disks. I had some cases where customers asked me, I need 100 gig disk and I need 2000 IOPS, so what do I do? 100 gig means P10, but what do I do? In that example, right, the P10 should not even come into the picture. So in that example, if you need 2000 IOPS, you need a disk that will give you 2000 IOPS, and you will pick P20 disk for that example. So that's how you would design your disk specifications. Okay. So the steps you would follow will be, if you really, and this is very important. So when you think about moving to premium storage, you would want to do some groundwork before you pick your configuration. Otherwise, you will end up with a configuration that is either not good enough for the performance you need, or you pick something that is too big and you waste a lot of money. You don't want either. So you would want to look at your workload, how it needs to perform, how you can optimize it, and essentially start with knowing what exactly is the capacity, IOPS, and throughput that you need from premium storage. Then based on that, you can then figure out the disk offerings that you will need to meet that performance. So it goes back to the first slide I showed earlier. You have the different disk sizes, and you have to pick the one that matches for you. So once you do this groundwork, you can then pick the right configuration. So let's look at an example here, right? If you think you need a terabyte of data, and you need 10,000 IOPS, what you will do is to pick 2 P30 disks, because you need 2 P30 disks to get 10,000 IOPS. And you could swipe those and create a single volume with 10,000 IOPS. The most interesting thing here, this configuration still gives you the the best value, if you compare with other cloud providers, is still less money than any offer from other competitors. So I compared with one of our competitors, and it's 30% cheaper than our competitor here. And also keep in mind, premium storage keeps three replicas for durability. What that means is that you don't have to worry about using RAID for saving your for durability or anything like that. You can just use the disk as is and trust that it will be there. Whereas in some of the other competing platforms, they talk about losing your data X% of the time, X% per year, and so on, and you will end up having RAID arrays and spend money on that. And that's not even factored in this 30% figure here. So the way we designed the premium storage offers and the I/O specification, throughput specification, and the cost is that you get the best value, best price for I/O intensive enterprise applications. And we made sure that premium storage gives the best value, best price compared to all our competitors. So that's our goal here. All right. Let's move on to some specific migration, specific consideration when you migrate from standard storage to premium storage. So we already talked about picking the right VM based on the specifications and the application performance that you need. But the most important thing to remember here is that the VM that you have on standard storage today, the VM size, may not be the size you would need from premium storage. And you will be pleasantly surprised to know that in many cases you can get even better performance with smaller VM, because premium storage disk performance is far better than standard storage disk performance. So you could in fact save money with VM on premium storage. I'll talk about some examples. I'll talk about some more details, and that'll be clearer here. Let's say you have a D4 VM today, and the reason you are using D4 VM is that you want 8,000 IOPS. The way you would get 8,000 IOPS from standard storage is with the use of 16 disks. You need 16 disks, each gives you 500 IOPS, so you get 8,000 IOPS. Let's say that's your application needs, and that's why you are using it. Now, if you want to move that to premium storage, a DS3 VM can give you over 12,000 IOPS. In fact, even a DS2 VM may give you what you need if you use the caching in the right way. That means your cost on the VM is half or a fourth. Now let's look at one more scenario. If you're using a SQL Server or Oracle or some software that is licensed per core, then your cost is going to be even less, because you have less cores used here. So many customers will find that moving from standard storage to premium storage with equivalent performance, you really save a lot of your cost. Your disk, the cost for your disk, individual disk will be higher, because these disks are faster and better than the standard storage disks. That part is clear. But when you look at the overall cost of the VM, cost of your license, and overall experience, it's going to be far better on premium storage as compared to your standard storage VMs. Okay. Now let's talk about disks. So the previous slide talked about VMs. Now let's talk about disks. So here, when you pick so you have a set of disks that you operate in your standard storage based application, and you want to move on to premium storage. So again, you wouldn't want to move the disk as is. You want to design what kind of disk you need based on the performance and the application patterns you want on the premium storage, and then pick the right disk sizes accordingly. And one other thing I want to call out here is that there are two things go hand in hand here. One, you want to pick a size that caters for your peak workload. If you expect, let's say, peak during Christmas time or some kind of a peak in the year, you would want to design for that peak. And you would also want to design for future growth. At the same time, Azure recently released a feature that allows you to expand your disk in place. Like if you have a let's say you pick P10 disk today, because that's all you need today, then when you're using an application, and your business, in a few months down the line, your business really takes off. Your business grows, your data grows, and everything is great. You want a bigger disk. You can increase the disk size in place. You don't need to do any kind of migration, copying, nothing. So Azure has the unique functionality. Nobody else has it. Unique functionality to increase the disk size in place. That really helps you plan in the most cost-optimal way. So that's another thing you need to think about when you design. Now let's just to recap that in an example. Today, if you have, let's say you have a stripe of 4 standard 1 terabyte disk. A lot of you have that to get the 2000 IOPS. A single disk on premium storage can give you that. A P20 can give you that performance. If you need more capacity, you could even use a P30 disk. So this is the kind of patterns you need to evaluate when you decide what kind of disk you want to use for premium storage. Okay? And we talked about the cache setting. So today for standard storage, there are some specific guidelines for how to pick the cache setting. Those guidelines don't apply for premium storage. We talked about the premium storage caching methodology, and you want to design your caching according to premium storage. All right. Now, when it comes to really migrating your data, like once you decide the configuration, everything is all set. Now you want to really do the move. So there are a lot more things in that process, and we have detailed those guidelines in our documentation. I encourage you to look at those guidelines. There are details that I will not be able to cover in this forum. And also, depending on your application that you're migrating, there are other details you would need to be aware of. Let's say you're migrating a SQL Server. There are very specific details about SQL Server migration that you would want to be aware of, and those details are provided in the application migration guidelines. SQL Server team has provided SQL Server migration guidelines for premium storage. I encourage you to look at that if you have a SQL Server migration scenario. And I want to call out a few other points in the migration that are important for migration. One is that if you have an existing cloud service resource group today, and if you want to convert some of those VMs to premium storage, there's a restriction that you need to be aware of, and that is the existing resource group cloud service cannot have a premium storage VM. Premium storage VM needs to be in its own resource group. You will need to create a separate resource group for that. If you have an existing virtual network, and if you want to use the premium storage VM in the same virtual network, you can, but you need a wider virtual network. That means you need to make it a regional virtual network, and only then you can add the premium storage VM into that. And you already know the 35 terabyte limit of provision capacity on a single storage account. So if you need more than 35 terabyte for your system, you would need to create multiple storage accounts and spread your disks across multiple accounts, and to stay within the limit per account. Okay, and if you are deploying a custom VM, so what custom VM is where, so let's say you have a VM and you want to take a backup of that VM and deploy it somewhere else, right? Or maybe you need multiple replicas of the same VM. That's what we call custom VM deployment. So in that scenario, the max size you can have for premium storage is 17 terabyte. You cannot have 35 terabyte. It's only 17 terabyte. Okay. So let's quickly touch on Linux support. I talked about the fact that we provide the same kind of performance for Linux as Windows. So here are the distros that we support for premium storage. In fact, across Azure. So we have this list posted on our website. You can look at that. The main thing to call out is that there are a couple of distros, as you can see highlighted here, require the latest LIS 4.0 driver installed manually. It's not part of those images right now. So in future, as we have newer images come out from those distros, those drivers will be part of it, and you wouldn't have to do anything. But at the moment, if you are using any of those like CentOS or those Oracle image, you will need to install those latest driver. Okay. Then just to call out that actual performance that you get can vary depending on the specific distro. So the VM that you demoed was the Ubuntu VM. If you use other distros here, we have seen that performance varies depending on the settings those distros pick. So each distro is optimized for different kinds of workload. So you will get different kinds of performance variations, or some workload will run better on some VM, some type distro versus other distro. So that's need to be, you keep that in mind. And you should look at the Linux instruction we have on our site. Calls out a few other optimization and other things to know of using Linux. Okay, so that wraps up the migration topic. The last topic I want to touch on is some of the backup related aspects. So let's look at that. So right now, if you have a premium storage VM with obviously VSTs in disks based in storage, the way you backup will be to take snapshots of those VSTs, and there are storage REST APIs that are out there for calling those backups, and you can schedule them for the specific frequency that you need, and so on. And once you take those backups, you would want to copy them over to a different storage account. Let's say a GRS account for a geo-redundant, keeping a geo-redundant copy of that data in case something happens to your premium storage VM. So there are some restrictions today when it comes to copying the snapshots. So you cannot directly copy the snapshots from premium storage today. You have to make a copy of that blob in the same account first, and then you need to copy that over to the standard account. So we continue to work on improving this experience, and we will have a little more improved experience coming up soon. And also there are some tools available, PowerShell tools and other tools available to make this experience better. And these are the processes I outlined here are for backing up live VMs. Like if your VM is running and you want to back up, that's when you need to use this process. If you have a maintenance schedule for the VM where you shut down the VM and do a backup, that process is very easy. You can shut it down and copy the blobs, and you have the VM backed up, VM and disk backed up. I want to also quickly touch on Azure Backup Service. So this is the process that this is the right process for backing up premium storage. So this process for the Azure Backup Service for VMs and disks currently is in preview, and it doesn't support premium storage at the moment. They just launched a preview and they're building more features, so it doesn't support the premium storage at the moment. And the support for premium storage is coming very soon. So once you have the support, then you can go to the backup service and schedule backup for premium storage VMs. So until this capability lights up, you would use the storage REST API for doing snapshots for premium storage VMs. Okay. All right. A few additional points to call out. A lot of you want to look at analytics. You make decisions based on analytics, performance of your VM, the level of the traffic you see on the VM. You may need bigger VMs if the traffic is going up, or smaller VM if it's going down, all that. So for analytics today, we provide the throughput metrics for disks on our portal, new portal. And we continue to add more and more metrics to that. So you will see more information lighting up on portal, and you should leverage that information for planning your VMs and monitoring your VMs. And of course, for additional performance details, you can use the tools. You can use some tools from within the VM, like perfmon or IOStat, and maybe other tools to see to monitor the exact IO performance of disks or other network performance aspects. If you are planning to use storage REST APIs, including for, we talked about snapshot, and if you want to use it for snapshot, the main thing to remember is that if you want, for accessing premium storage through REST APIs, you must use the latest storage REST version. You need to use a version later than 2014 Feb 14th. Then there are a couple of other restrictions you need to be aware of. One, public containers are not allowed on premium storage accounts. If you want to share something publicly, the process for that will be to create create SaaS, and if you want it to be sort of like an infinite SaaS, you will want to pick a year that's far out into the future. Let's say you can put 9999 as a year. That essentially gives you an infinite SaaS, which you can share with other people and share a particular premium storage objects. And lastly, if a VST is part of it, VST is mounted on a VM. VST is really essentially what it means is that you have a disk using the VST, and the disk is mounted on that VM. In that scenario, you cannot directly read from the VST. Only way to access the VST in that scenario will be either take a snapshot, then you get a snapshot and you can read from the snapshot, or you can detach the disk and then access the VST. The reason is that when the VST is mounted on a VM, it's locked for access by the VM, and VM is reserving all the access and IOPS and everything on that disk. Okay, so that wraps up the backup scenario. So before we wrap up, we have additional resources available to you. We have given some links at the end of this deck. I encourage you to visit these links and to learn more about premium storage. We've given a lot of information about the how to use, a lot of instructions for migration, and there's also a channel and video on premium storage. So you have a lot of information you can get from these links. So I encourage you to check that out. Yeah, thanks for coming over.